Hello guys, welcome to Big Book. Today we are going to discuss the Anthrones test. It is the quantitative test. Earlier to this we have uploaded the similar kind of slides for qualitative test, which is the simple way of identifying the compound. Now whatever the sample has been taken into consideration. But here in this it is a quantitative test. Here the estimation will be done, that is what the amount of the compound will be present or what the weight of the compound will be present within the sample. So it is the general test for all carbohydrates. So before to the detailed explanation, a principle we are going to repeat, that is concentrated sulfuric acid is going to hydrolyze the glycosidic bonds to yield monosaccharides, where carbohydrates dehydrates in presence of acid to form furfural like aldehyde and its derivatives. Thus the formed furfural derivatives react with anthrone to give a bluish green complex, that is the end result. Polysaccharides and glycoproteins also give a positive reaction. So here not only the monosaccharides, even the polysaccharides and the glycoproteins are also going to give the reaction with the anthrone. The only difference between the qualitative and quantitative principle is that in qualitative principle or the method of the identifying the compound is that there we are not going to amount the concentration of the compound present in the sample, but here in the quantitative we are going to see the concentration of the compound within the given sample, where we are going to measure by using calorimetrically at 620 nanometer. We will slightly discuss the principle in the form of the formula, where we are going to see this is to be as the D-glucose, that is dextrose glucose, and here where it is going to react with the H2SO4, giving out the 3 water molecules and reacting to give the hydroxymethyl furfural by adding the anthrone as the bluish green complex. So here you can see within this particular image, that is this is the end result, how the bluish green complex will appear. Now here I said the hydroxymethyl furfural or the furfural is the aldehyde derivative. Here you can see this is the aldehyde. This is how the formula is. Further, with this bluish green complex formed in the test tube samples, all this will be taken into the calorimetrically at 620 nanometer and measured the absorbance of the light at 620 nanometers, and further those will be plotted, and further the whatever the concentration amount of the sample, concentration amount of the sugar in the sample will be identified. Coming to the preparation of the reagents. Anthrone reagent dissolve. So here in this we have to dissolve 200 mg of anthrone reagent in 100 ml of concentrated H2SO4. So here we have to dissolve, we have to have a note of H2SO4 should be ice cooled before adding to anthrone reagent. So here you can see this, it should be ice cooled, otherwise there can be any incidents of the accident which can cause or it can be hazardous. Now here we can see the standard glucose preparation. First we have to prepare the stock standard, where we are going to weigh about 100 mg of microgram of the glucose and transfer it carefully into 100 ml with distilled water. 100 mg of glucose in 100 ml of distilled water. So here we are going to dissolve. Further out of that we are going to take the working standard, where we are going to dilute 10 ml of the stock standard. This is the stock standard where we have prepared 10 ml of the stock standard solution in 100 ml with distilled water in a volumetric flask. So here that will be the working standard. So these are the two reagents. One is the Anthrone reagent, how we are going to prepare, and the other is the standard glucose solutions. One standard is the stock standard. Out of the, after preparing that, we are going to prepare the working standard. So that is the other one which we are going, working standard is the one which we are going to taking into consideration for the further procedural steps. Now here we are going to prepare the standards sequence like 0.2, 0.4, 0.6, 0.8, and at the end 1 ml. That is, we are going to take almost 5 test tubes, and we are going to add one more test tube to that. That is going to be the 0 ml, that is the blank. After that there will be 0.2 ml of the working standard solution in one test tube. Next will be 0.4, next will be 0.6, and next will be 0.8, and last will be the 1 ml. So this first test tube will be always blank, which will be having the distilled water, which will be equivalent to the last test tube's volume. So here 1 ml will be the 1 ml of the blank distilled water, 0.2 ml of the working standard, 0.4 ml of the working standard, 0.6 ml of the working standard, 0.8 ml of the working standard, and 1 ml of the working standard. So after that we are also going to add 1 ml of the unknown to be estimated. So here already we have discussed about the blank of 1 ml distilled water, that will be the first test tube, and unknown will be the last test tube after the 1 ml of the standard working. So here almost we are going to take around, first will be the blank, last will be the unknown to be estimated. In between whatever the samples measured are the working standards. So further we are going to make up the volume in all test tube to 1 ml. So here whichever the test tubes are having lesser than the 1 ml of the volume, that is from 0.2, 0.4, 0.6, 0.8, we are going to add around 0.8, 0.6, 0.4, 0.2 ml of the distilled water. So here we are going to make up each test tube to be to the 1 ml. Next is, after that add 4 ml of Anthrone reagent in each test tubes. So here including the blank and the unknown and all the sequence test tubes from 0.2 to 1 ml, what the working standard we have taken, to all the test tubes from first to the last, we are going to add 4 ml of Anthrone reagent. So now place all the test tubes in boiling water bath and heat it carefully for 8 consecutive minutes. After boiling under water bath for 8 consecutive minutes, we are going to cool down the solution as fast as possible, and carefully we are going to read the color till it changes from green to dark green color, and also add 5 ml of distilled water to each test tube to make up the volume to 10 ml. So now adding the 5 ml of distilled water to the test tubes, the total volume is going to become to the 10 ml. Now further we are going to measure here 6 point, we are going to measure the optical density in a photoelectric calorimeter at 620 nanometer, or by using a red filter. So here we are going to do this. Now further, after taking the readings for each and every test tube, we are going to plot the graphs and we are going to study the result. Now this is how we are going to make the table within the practical record, where first will be the serial number for the test tubes, and further will be the volume standard glucose in ml. Now here this will be the whatever the standard amount of the glucose will be present. For the blank, as it is for the distilled water, there will be nothing, there will be nil for the glucose. Further, whatever the 0.2 ml standard working solution we have taken, this is the amount. For 0.4, this is the amount. 0.6, this is the amount. 0.8, this is the amount. And 0.1 ml, for 1 ml, the 1.8 is the amount of the glucose. and for the last 7th test tube it will be unknown, because that we have to identify after doing the whatever the estimation procedure is there. Now here further we see that this is the making up of the volume to 1 ml. Now here this will be the adding of the 4 ml of Anthrones reagent. This will be the keeping the test tubes for the boiling water bath and boiling it for 8 minutes, and this will be adding 5 ml of distilled water in each test tube. And further is the absorbance which has been recorded here. So here you can see the different readings. For the blank it is 0.0, so here for 0.1, 0.22, 0.31, 0.44, 0.53 and 0.2 is the readings. Now this is the slide of absorbance of 620 nanometer, where we have got the readings and it has been plotted on the graph. You can observe that in the graph this is the absorbance readings, and this is the glucose standard. This is the unit for the absorbance, and here these are the readings of the absorbance which we have got. Now here for the unknown we have the reading is going to be placed here. So here for the whatever the standards we have taken, working standards, those has given the exact readings which has been placed accordingly. But here for the unknown we have got here as the intersection between this 0.2 absorbance as the reading, which is going to fall here on the standard curve. So it is going to fall here and the intersection is going to come here. So here with the help of this intersection, further we are going to do the calculation. Here the calculation is to be like, this is the formula: absorbance of unknown divided by concentration of unknown, absorbance of standard divided by concentration of standard. So here concentration of unknown, CUN, is the concentration of unknown, so that is what we are estimating here, is equal to absorbance of the unknown into concentration of the standard. Here this goes here and absorbance of standard comes to the denominator. Now here we have the readings of absorbance of unknown is 0.2, absorbance of standard is 0.22, concentration of the standard is 0.72. So here we have to identify the concentration of unknown that is to be estimated. So this formula has been taken here and values has been placed. So we will get the concentration of the unknown to be 0.654 mg per ml. So as we are estimating for the 100 ml, it is going to contain, and we are going to multiply this 0.654 mg per ml into 100, and it is going to give 65.4 mg per 100 ml. So this is the result. So we have estimated the unknown sample containing the glucose amount to be 65.4 mg per ml. So this is the brief amount of explanation on Anthrone's test for estimation of the monosaccharides, that is the glucose which we have considered here, and we are given the appropriate result. Thank you for watching this slide and hope you guys will follow these slides, and if you have any questions and doubts and queries, please ask us, and we are ready to clarify it.